It's been a while, but we're back to organic chemistry, and today we're reaching back to the basics. Today we're going to cover some alkanes and all about alkanes, how you make alkanes and what you do with alkanes, so how they react. Okay, alkanes. What do we know about them? Alkanes, first of all, we know their chemical formula. We know their general formula is C, N, and H 2n plus 2. This is your general formula. We also know that they are saturated because they have CC single bonds only. Well, let's discuss just very rapidly some physical and chemical properties of this alkane. Alkanes we know for solubility. Solubility goes down as the CH bond chains grow longer. So basically as molar mass increases. What we also know is that if there are an odd number of chains, then it's going to have more stacking, like this. For example, if there's 1, 2, 3, 4, 1, 2, 3, 4, even number of carbons, then it's going to fit right into each other. But if there is an odd number, they're going to stack right onto each other like this. And this creates more depth, more thickness, whereas this creates little thickness. So this odd number of carbons have more packing. And therefore, because of this packing, their point of freezing, or more accurately, their point of melting, I guess, will be lower because it's more densely packed. That's pretty much all you need to know, mostly for the properties of alkanes. Now let's move on to the important part, which is how do we make them? There are mainly two methods for making alkanes. Let's start with cracking. Cracking is really simple. Cracking is when you get some kind of large hydrocarbon, and then you crack it using heat, under immense heat and pressure, into lots of small alkanes and alkenes. All you need to know is that the number of carbons on the left and the number of carbons on the right have to be equal to each other. For example, if I have some kind of octane, C8H18, then I could break it into perhaps propane and pentane. The number of carbons on this side, 3 plus 5 is 8, and on this side is 8. These two are equal to each other, so that's good to go. Okay, now, what is the second method? Second method is something more interesting, and we call it hydrogenation. This one has a special condition, which is either a platinum nickel catalyst or a palladium on carbon catalyst. So, what happens in hydrogenation is that you take an alkene and you add hydrogen straight into it under one of these catalysts, which creates an alkane. Let's give an example. Let's say that we have ethene, which by its formula gives C2H4, like this. And let's say that we have this C2H4 on this catalyst, such that it looks something like this. Then we have hydrogen, which we're going to draw here. Both go under homolytic fission, such that it turns into radicals. And at the same time, this happens, where the carbons also become radicals. And these two bond to each other, which makes an alkane, like this. So that's the process of alkanes being made. So those are the two two main production processes you need to know. What are the reactions? Well, let's start with the basic one, which we can probably imagine exists, which is combustion. Combustion is a pretty simple reaction. There's two kinds. There's complete combustion and there's incomplete combustion. Let's say you have an alkane. Here's the difference. You add an oxygen, but if you add an excess oxygen, then you will get CO2 and H2O as a product. Of course, remember to balance it out. However, if you add in limited oxygen, then you will get carbon monoxide and H2O as a result. This is why you often put in catalysts inside of these reaction chambers in your cars so that they don't create carbon monoxide because it's susceptible to carbon monoxide poisoning. Now the second reaction we call free radical substitution. Free radical substitution. Now this is when you have some kind of alkane and you react it with some kind of halogen, HAL2, under, this is very important now, UV light. UV light. And under UV radiation, it turns into an halogenoalkane. Let's look at this process in detail. Let's say we have some kind of methane, which is an alkane, and let's say we have bromine. Under UV conditions, how does this turn into a halogenoalkane? Well, let's start with the first step, which is called initiation. Under initiation, we first see the halogen break up into two halogen radicals. So Br2 turns into Br radical and another Br radical. Thus, if we look at it more specifically, we can see it go under homolytic fission. Homolytic fission. This is the initiation step. Now what's important is the propagation step. Propagation. In the propagation step, one might imagine that the alkane now has to react with one of the products of the initiation. So the alkane now reacts with one of the Br radicals. Now what happens here? Well, if we draw it in more detail, CH4 is like this. The free radical is here. The free radical is extremely unstable. So now what happens is it's hungry for a more positive, partially positive area, and that happens to be the hydrogen that's over here. Therefore, this bond breaks here, which creates a methyl free radical plus HBr. I forgot to add H-hal, so a hydrogen halide. So this turns into a methyl free radical and HBr. Now what is the termination step? For this reaction to end, this reaction goes on endlessly until it's terminated. And when it is terminated, you just simply have to write down all of the radicals that were in this reaction, which for us was Br radical and the methyl radical. So the bromine radical and the CH3 radical, think of all possible combinations. Br with Br, which creates Br2, Br with CH3, which creates CH3Br, and CH3 with CH3, which creates C2H6. So all of these are products of the reaction. The bromine, the bromo methane, and in addition to that, we have our ethane. So all of these are products to the free radical substitution, and those are the alkane production methods and the reaction methods.